When you download the template from Sunlearn, you will find three files. The one is your ASC file. This is your design template file. Then there's an external file called config.txt and PW input, which stands for piecewise linear input.csv. So just want to show you where they tie in real quick. If I open up the design file, this is the template that you're going to start off with. Remember to rename it. In this block, don't touch anything, please. This is where we import and export the signals that we need to auto-assess and to generate stuff. So typically, you would have added these in your simulation control here. But what we've done is we've automated those. So don't touch these. You can play with it if you want, but you need to revert to what they were before you submit, because that's what we use to assess you, or your circuit rather. You can see we have three voltage sources here. They just introduce different signals, but the important thing to note is we also have an include E344 config.txt. So I'm just going to open that real quick. This is what it's about. We have a few parameters in here. This is the DC amplitude with which we will introduce DC at some stage. The sine wave offset if we wanted to introduce another DC amplitude, and then the sine amplitude. So the noise that you have to filter as part of your design is specified by sine amplitude and another parameter that we defined, sine frequency. So by setting the amplitude here, we will check that you suppress this signal. So you need to set this to the appropriate noise amplitude level when you develop. So we've set this to be 1 degree Celsius. So if your 1 degree Celsius is equal to 5 millivolts, you need to change this to 5. If it is 55, you need to change it to 55 millivolts. So this is the amplitude. The sine frequency here is 50. That'll just be 50 for everybody. And then we also have here just the simulation parameters. So the transient analysis starts from 0. It runs up to 500 milliseconds, and the time step that we specify is 0.1 microsecond. So that's the config file. So as I said, this config file is imported here, and those values are used in the setup of the simulation here, and then also in the DC amplitude here, the sine offset here, the sine amplitude, and the sine frequency. That's how they feed in. But one of these external inputs is also from the piecewise linear input. This piecewise linear input you can see is specified here, and this is equivalent to, if you look at the voltage source here, I've got piecewise linear input.csv. It pulls it in from there. That's why it says piecewise input linear CSV. And if I open that file, you can see this one contains, just want to pull it up again, this one contains the time in the first column, and the second column is just the value. So you need to convert this to give you the appropriate inputs. It's currently set to one of the input parameters. Essentially, you need to specify here your midpoint, which is the middle point between 42 degrees and 34 degrees. You need to specify that voltage level there, and then the 34 degrees level here, and the 42 degrees level you need to specify here. So this is what we'll use to auto-assess, and each one of you need to convert this PW input as you please, what you want, whatever you want to put in here while you develop, and then we will populate this file when we auto-assess. The only other thing to mention is that, as I said, nothing is to be touched in here, but your output must be connected to this. So we've put a label down here called Vout. Vout. You need to connect Vout on your circuit. So on your circuit, you need to name one of the last labels. The last label that you introduced must be Vout. Don't give it two names, otherwise there will be a clash and the auto-assessor won't pick it up. So be sure that you have on the output, your output of your circuit has a netlist name called Vout. And then you draw the 9 volts from the 9 volts that we provide.